All right, so we're going to do a second lecture for today. First half was on GitHub. Second is on making two-dimensional vectors in C++. So again, for GitHub, you're going to do these steps one time, make an account, make a repo, add collaborators, and then clone it down to your machine. And then over and over again in a loop, you're going to pull to get the latest version, edit the files, compile them, test them, make sure they're good, git add, git commit, git push, and now they're back up on GitHub, and then your collaborators can do a pull, and so on and so forth. So see the previous video for more details. So cdf up, remove -rpg40. This is how you delete a folder. Don't do this unless you know what you're doing. Okay. So today we're going to be talking about doing two-dimensional vectors. So a two-dimensional vector is like, imagine like you want to make chess or something like that, right? And you need to store data sort of in a two-dimensional layout, right? You've got rows, you've got columns. You typically say them in that way too. It's rows first, then columns. So y is first, then x, which is a little bit different from, you know, if you're used to algebra where x comes first, then y second, you know. So last time I went on a bit of a rant about how arrays suck. Like you should never write array like this, any of this kind of stuff. There is one place where arrays have at least one minor advantage over vectors, and that's when it comes to two-dimensional arrays. Simply because if you want to make like a chessboard, how big is a chessboard? It's like 8 by 8? 8 by 8, yeah, okay. So if you want to make a chessboard, you can do it like this. And if you do something like that, it'll initialize everything to 0, the null character. And then you could like do something like this, like row 0, column 0 would be like the black rook, and row 0, column 7 would be a black rook, and row 0, column 1 be the black knight. Not you. 6, 3, and 5 be the bishops. You guys know what I'm getting at here? So this is how you make a two-dimensional array. Square bracket 8, square bracket 8. And then you can just say square bracket row, square bracket column. And so we're saying row 0, column 0, put in a rook. Row 0, column 7, put in a rook. Row 0, column 1, put in a knight. 6, put in a knight. Do you guys know what a chessboard looks like? Right. So you got the knight, the black rook, the black knight, the black bishop. Then you got the queen and the king. Right, so did I miscount? Yeah. Oops. And so the black queen and the black king, something like that. So that's the back row, and then you can do the same for the pawns and for y and whatnot. So y is first, yeah. So this is row 0 up here. Typically, row 0 is the top row, and you count downwards. Because in computer science, the top left corner of the screen, right there, is row 0, column 0. And then this I would be row 0, column 1. The N would be row 0, column 2. The C would be row 0, column 3, and so on and so forth. So the columns go downwards. So it's not just Y is first, but Y goes down, and then X goes to the right. Screen coordinates, I don't want to tell you. It's just a convention. So this is something that is nice about arrays. Now, however, all the other downside to arrays exist. If you pass them to a function, they don't have any size, and passing multi-dimensional arrays to a function is especially annoying, and they're terrible, and we don't do it. So let me show you how to make a vector of chars. And I apologize in advance. The syntax for this is kind of garbage, and you're probably going to have to look up this video every time you make one. So there we go. If you want to make a two-dimensional vector of characters, you're going to make a vector of characters. Why is there no 2D class for holding two-dimensional data in C++? I don't know. I hear it's coming in 2023. We'll see if it takes place. I don't know. 40 years later, we get a matrix class. I don't know what to tell you. So we're going to make a vector of vectors named board. And we're going to have int const int rows is equal to 8 and columns is equal to 8. It's an 8 by 8 board. And so each row is going to be a vector of characters of size 8. So we are making a vector of vectors. So each element of the vector is itself a vector. And so we're making basically each row. But then each row is 8 characters long. I shouldn't put an 8 there. That is a magic number. That is a no-no. Let's do calls like that. Okay. That's how you make it. All right. So if you want to compare and contrast, here is a place where, to be fair, the 2D array actually kind of looks a little bit better. It's just, yeah, it just does. The two-dimensional vector is just kind of not good. I don't know what to tell you. So that said, whereas before we could say something like, board. So before we could say like board 2, 5 is equal to queen or something like that. We can actually do the same thing here. We can actually say board square bracket 2, square bracket 5 is equal to the queen. That's actually perfectly valid C++. The only difference between the array and the vector here is that you get all the benefits of the vector. After that, it's almost a drop-in replacement. You can actually do it just like this. This means row 2, column 5. So 2 rows down, boom, boom. 5 to the right, we're going to put the queen there. Okay. And that said, we in general don't want to use square brackets because it does not do bounds checking. Now, if you know what you're doing, you need the speed, you can use square brackets. Not in this class though. Okay, so .at 2 .at 5 is equal to the queen. So that is fast and unsafe. So not recommended for this class. This is slow and safe. Okay, and so this is the recommended for CSI 40. Okay. You don't need speed in this class, and you are probably going to screw up at some point. True story. So, you guys see what's going on here? So basically, we can set any piece. How big is the speed difference? If you're making like one move every 5 minutes, if you're making one move every second, you will not notice any difference. When I say like slow, it's slow in the sense of if you're doing it millions of times per second, it'll be probably about twice as slow. So it is noticeably slower. But if you're not doing it in a hot loop that's running over and over again, you're just not going to see any difference. And so you can do your development using .at, and then after you know that you're not going out of bounds, you can replace them with square brackets. That's fine too. But I mean, most applications are still, time sensitive, and so like I'm not 100% opposed to square brackets. I'm opposed to that though, because these things do not contain size information, right? And so just use something else instead. Now, vectors have their own issues, but they don't really matter for this class. So, okay, so how would I set row 5, column 6 to be the king? Can somebody give me some code on Discord setting row 6? What did I say? Row 5? I don't remember now. Row 5, column 6? I don't know. To the king. The numbers don't actually. Row 5, column 6, set it to the king. One of the kings. Uppercase king. Good. Okay, so, it's basically all there is to it. The setup is the only part that's kind of annoying. And just memorize that pattern. If you want to make a vector of doubles, you can do so. So what kinds of applications does a 2D vector have? Well, a lot. So 2D data structures come up like all the time. Anytime you're working in physics, maybe you're doing a 3D data set, but the reality of the situation is that like computer science people get hired all the time to work in physics and to work in physical sciences and applied math, things like that. Because what happens is like physics majors take like one semester of computer science, usually. Then they get into like their senior year of grad school and they realize it's all computer science. And then they oftentimes have to call in an expert. So like, it's like, you take one semester of Spanish in high school and then you go to work in Mexico City. You're like, I might need a translator here, And so I actually worked, quite a few different jobs. Oh my gosh. I worked quite a few different jobs where I had to basically be the computer science expert in bioengineering, applied math, biology, in different contexts, because like they study a little bit of computer science, but like when it gets down to it, like they just don't know enough to like really do it well. So a very common thing in physics is doing like simulations of physics. So let's imagine that we have this board here, but we're now going to call it like a sheet. It's like an aluminum sheet, and we're going to fill it with random temperatures, and we're going to simulate the temperatures averaging out like heat transfer, you have a hot area, you have a cold area, and the hot area will kind of like warm up the cold area, and then it all kind of like evens out over time, So let's start off by initializing it with random temperatures. So we'll say for every row in the sheet, for every double, for every column in the row. This pattern here, you should probably get used to also. If you don't want to type auto, this could be written as a vector of doubles. That's a lot of typing, so why type it? And auto here could be replaced by just double if you want. But this pattern works pretty well. So for every row in the sheet, for every column in the row, so this is essentially going to go over every point in the sheet. What we want to do is we want to set the value of the sheet equal to the average of its neighbors. And let me draw this out. This is actually something that comes up a lot. There's like a Jacobi approximation for like ordinary differential equations. There's Gaussian blurs and all sorts of like image filters and things like that. All kind of follow this like 2D stencil. So imagine you have like a grid of data, and this again is a pattern that just comes up all of the time. Okay. So you got, I'm just going to draw like a 5x5 here. Yeah. I'm just going to fill it with random numbers: 5, 0, 6, 3, 7, 10, 2, 4, 12, 22, -3, 19, 3, 5, 16. Okay, it doesn't matter. Point is, we're going to start off with just random temperatures. And then what we want to do is repeatedly, we're going to loop over the entire sheet of aluminum, and we're going to set each point to be the average of either its neighbors or its neighbors and itself. There's all sorts of different stenciling operations. But basically what you're going to do is you're going to apply the stencil to the array over and over again. And you're just going to add up these 5 numbers. So you're going to add 4 plus 6 plus 7 plus 22. That's 10, 17 plus 22. is 39. 39 divided by 5 is almost 8. It's 7.75, I think. Get the math right. I probably should have picked smaller, easier to do numbers. Just make sure I did this right. 10 plus 7 plus 25. I've not had enough copy today. Divided by 5. 7.8. Sorry, not 7.75. 7.8. And so what's going to happen is the value of 6 here is going to be replaced with 7.8. Now, it doesn't take place immediately. What you're going to do is you're going to run this stencil. You're going to do it next, here. And what you do is you loop over the entire 2D array, and you've got another 5x5 array over here. And what you do is you write the output value into that. And so now we're going to move on to here, and we apply the stencil to this. We've got 5 numbers. 3 and -3 works out to 0. 6 and 7 is 13 plus 2 is 15. 15 divided by 5 is a nice even 3. Thank you for working out correctly. That was complete chance. And then, do you guys see how this works? So basically, you do a for loop that says for every row, for every column, compute the average of its value and its neighbors and write it into a second 2D array, which I don't have right now. And this one is going to be 2 plus 10 plus 7 plus 5 plus 11. 9, 20, 30, 35. Oh, perfect. 35 divided by 5 is 7. Okay, so do you guys see? Do you understand what's going on here? Like, you just basically loop over the entire thing, and for each point, you compute the average value at that point, going up, north, south, east, west. Yep. And so I'm going to show you what that'll look like, kind of. I'm not actually going to be doing the double buffering, which you need, because if you don't, it's going to smear the values around, and it's going to look really ugly, but whatever. So for every row, for every column in that row, I'm going to set that column to be some random number modulus 100. Okay, so I'm just going to give every temperature on this sheet a value from 0 to 99, and then I will print it, I guess, y, and come down here. Yeah. For I'm just going to print everybody's scout the column. And then after that, I'm going to do this for loop. Now, I'm going to cheat slightly because I'm not going to handle the edges. Handling the edges and the corners is the most annoying thing, because you've only got 2 neighbors instead of 4 neighbors, right? And so, like, numerically, like, that causes problems because it's not going to average in the data as quickly. So a lot of times, like, you'll wrap around and like have this one connected to this one and this one connected to this one. Or if it's just in the corner, you just connect the 2 and then it just changes a little bit more slowly. Or, if you're really bad, you just go out of bounds. You try accessing what's over here, and then the code crashes. So I don't want to do that, and I also don't want to handle the special case because we're basically out of time. So I'm just going to do it a cheap way. I'm going to say int row equals 1 instead of from 0. I is less than rows minus 1. So I'm going to start 1 row down, and I'm going to finish 1 row up. So I'm not going to do any of the top row or the bottom row. I plus plus, y2y, paste. What is your, no. Okay. Call. Calls. Call. Okay. So I'm also not going to handle the left column or the right column. I'm just going to be doing this code on the inner chunk. In reality, I would need to handle the edges and the corners, which are the annoying parts of doing numerical simulations. And I've done many of these over the years, trust me. And it is just annoying. So what are you yelling about? Oh, thank you. Okay. All right. So we are going to set whichever point we're at. We're at some row and we're at some column and we're somewhere in the middle of this array here. So I'm going to say vector sheet dot at row dot at column. So I'm going to be starting at row 1, column 1, and then I'm going to go to row 1, column 2, row 1, column 3. So this is how you can iterate over a 2D array. Normally this would be a 0, right? And there wouldn't be a -1 there, but I'm just pulling it in a little bit. Don't copy this code pattern for normal stuff. But I'm kind of pulling it in a little bit so that I just don't have to deal with the edge cases quite literally. Okay, so sheet.at_row.at_column is going to be equal to the quantity of all of the neighbors and itself divided by 5. And you might be like, oh, does that work? No, it doesn't. I got to put something inside there. So what I'm going to put in is, so if I'm currently like at, this place here, right? This is row 0, row 1, row 2, column 1, column 2, column 3, column 4. So let's say I'm at row 1. I'm at row 1, column 2. I need to get row 1, column 2, sheet, row, column. Okay, so that's me. That's this guy, and then I need to add to it this guy. That's the person that's in the column to the left. And let's see if I can format this in a way that'll not look completely garbagey. So I'm going to add five values together. I'm going to add in this value, this value, this value, this value, and this value. Okay. So we're going to add in, that's the 7 plus row -1 column. So this one is going to be the 6. And then we're going to add in row +1 column, which is going to be the 2. So far we've added the 7, the 6, and the 2. We got to add in the 3 and the -3. So plus row column -1 plus row column +1. Okay. I don't know if this formatting bothers you. It kind of bothers me a little bit, but at least you can see the 5 different things. So this one here is like the 7. This one here is like the 6. You know, let me snap this to the side and pull this over to the side here. Okay. So this one is basically, you know, if we're at row 1, column 2, obviously, that's our example. That's the 7, that's the 6, that's the 2, that's the 3, and that's the -3. So we're going to add all 5 numbers together. So we've added together the 7, the 6, the 2, the 3, and the -3. We add them all together, divide by 5, and store the result into sheet.at_row.at_column. And I could have used square brackets for that as well. But does that kind of make sense to you all? And then we'll do the after. So every element is going to be set to the average. Okay, so you can see before we had all this data here. And now because we didn't work on the top row and the bottom row and the left column and the right column, you can see all those values are unchanged, right? But 21 is set to be the average of 86, 62, 26, 49, and 21. And so if we pull that up into this calculator, so for this guy here, it's 21 plus 86 plus 62 plus 26 plus 49 divided by 5, we get 48.8. Okay. So there you go. So each element is set to its neighbors. The trouble is, like, it's smearing, it's writing into the array, and then it's reading that value. So what we need to do is actually be writing into a second sheet and then switching the buffers. So this isn't quite exactly right. But that kind of gives you the idea, at least, as to what we're going to be doing for our next homework assignment. Not RPG, but the one after. Okay? So, you guys excited? Do some physics? It's not just all fun and games. It's not just all video games in this class. This is pretty useful stuff. Yeah. Physics comes up a lot in a lot of computer science applications. You'll be simulating physics in one way or another. Simulations in general are a very common use of computer science. You work in econ, you're going to be simulating the economy. If you're working in, I don't know, anything like engineering or science related. And this approach here of the stenciling, where you set a value equal to its neighbors, this comes up a lot. Imagine you're like this is heat transfer, but imagine you're like transferring stress, and strain. I don't know, those engineering concepts I don't understand. Water velocity. Like there's a lot of different like examples for this pattern that come up a lot. So that is it for today. Hope you guys had fun. You learned GitHub in the first half of class, which is, like I said, it's extremely valuable. It's de facto standard all throughout industry right now. And in the second half, you saw how 2D vectors work. They have this really ugly, I apologize again, way of making them. This makes a 2D array, 2D vector of size rows by columns. Okay, so it's rows tall and it's columns wide. And this pattern is just something you're gonna have to memorize until a new version of C++ comes out that supports two-dimensional data structures. So kind of stuck with this for now. It's not great, but it's not that bad either. I don't think it's too terrible. I'm not super happy with it, but it's not too terrible. And then this code pattern is great for just simple, like for every row, for every column, do something. And then this pattern is needed if you need to not go over the entire thing. Like we're not going over every row and we're not going over every column in every row, right? Because we're pulling it in a little bit. So you have to use a traditional for loop if you want to do something like that. If you're just going to be going over every row and every column in every row, then a range-based for loop works just fine. And using auto-reference is shorter than typing out vector angle bracket double closing bracket. Okay, that is it for today. And I will see you guys on Wednesday. If you need a group, hang out in the 41 chat, and I will get you guys all partnered up and ready to go. Okay, so collaborate one way or another on your project. Either way, collaboration is crucial in computer science. It's a really important skill to learn how to do. Okay, thank you, everyone. I'll see you next time.